So with that, I'm going to like to introduce to you a gentleman by the name of Dr. Gary Bram. I met Gary Bram I met him many years ago. But a couple of years ago, he brought up to me a design of an idea that he had. He's a dentist, just like you. He practices in New York. Maybe you don't practice in New York, but he does. But he's a general dentist, just like you. And he has some really brilliant ideas. And he's always coming to me with these ideas. And he's very smart. He comes up with some stuff. I don't know where he gets it from. His mind's always working. But he came to me with a revolutionary idea. And when I heard it, I didn't fully understand it 100%. But I saw that we were on the same wavelength with this. So I said, all right, let's take it to the next level. Let's see where this can go. And so by going to our courses and practicing and using some of these techniques and trying to create something, we did develop something truly, I think, extraordinary. So I'd like to invite him up here to discuss with you. He's a dear friend, and he's going to share this lecture with us.
Hi, guys. It's a pleasure to be here, and I'm just a regular dentist like all of you. I've been coming to these courses for quite a while, and as everybody else, I was absorbing, I was learning and listening. And one day, when I was sitting in the auditorium, like everybody's sitting right now, I look at the slide presented by Dr. Maurice Salama, and I was looking at the scalloping of the bone, and I was so impressed that I started to think, how do we achieve that? And at the same time, doing a proper osteotomy. This is the article by Maurice Salama, Professor Alessandro Pozzi, who I spoke to at his course. And at his course, he presented something like this. And what struck me is he was scalloping the bone, he was scalloping the soft tissue, and he was talking about preserving the bone. We all love to do all-in-4 and all-in-6, and there's nothing wrong with it. What's wrong is that we're reducing bone to the point where there is no sufficient amount of bone. And one of the phrases he introduced comes from Branimar, okay? And it says, surgery is not cutting, but a gentle handling of Mother Nature gifts. And that really, really brought the point to me, and I was obsessed. I was obsessed with finding a solution for scalloping the bone. Scalloping the bone and doing it at the same time as preparing the osteotomy. And this is the article by, again, Maurice Salama, Alessandro Pozzi, and the whole Atlanta team, which was presented in one of those seminars, and we all can read about it. So thinking and going to the drawing board, back and forth, and it took me quite a while, we finally came to the design of the drill, which was functioning, and we actually tested it. And this is the design of the drill. You're all going to see it in your kits, and later we're going to practice on the models, and we're going to show you exactly how to practice on the models, because we practiced on the models. So the first thing I did, I grabbed some models from Isaac's office and started to play with it. And we placed the standard implant, and everybody's doing that. Everybody knows how to do it. And what happens, we have lack of profiling. This is something what Isaac was talking about before, and this is what we started to do. We compared the standard placement of the implant versus shaped osteotomy for the same exact implant. And we shaped it with a kit, with the drills from the kit. And you'll see later that you can shape it either with one type of the drill or another type of the drill. You can apply one first and another second, and vice versa. This is the drill in action, and again, you're going to see it later. We put the mark on the drill, which marks the first millimeter of shaping and widening of the osteotomy. It's 1 millimeter mark, but it has 2 millimeter capability of shaping, flaring, and going deep 1 or 2 millimeters and wide 1 or 2 millimeters. This is the mark. You're going to see it on the drill. And as a matter of fact, now we are in production of the next generation of these drills, which will have more markings designed for soft tissue and indicating every millimeter of what you're doing in the mouth. And while we were designing the so-called bullet-shaped drill, which you saw before, what we realized, what's going to happen if we're doing osteotomy and we're shaping the bone to accept the implant, but next to it we're going to have a pontic, or we simply want to shape the soft tissue for a pontic, and we want to make it not ridge lap, we want to make it oval shape, cosmetically acceptable, to come from the gum and be very pleasing to the eye. So we created another drill. We created a drill which we call a scallop-shaped drill, or scallop. Somebody refers them to mushrooms, but it's actually a scalloping drill. And what you can use it for is, after you creating the first osteotomy, which is already flared, you can use this drill to create the shape for a molar, for premolar, for the canine, and basically whatever you want. By tilting the drills 45 degrees mesially and distally, you can create osteotomy, and you create a bedding for your future molar or premolar or whatever the shape you decide to use. This is the shape for a molar. And if you want to use it, if you want to use your custom prepared healing cap, this is a perfect bedding for that. And this is what's going to create a perfect synergy between your implant, a future abutment, and the crown. And what's the most important thing, it creates a wonderful environment for your soft tissue. Taking care of the bone, we're taking care of the soft tissue at the same time. Let's take a look how the healing cap's fitting in both osteotomies. On your left is a standard healing collar, the same as on the right, but on the left it's a standard osteotomy. On the right, it's the osteotomy done by shapers. And you can see on the right, we can fit it a little bit deeper. It covers the whole surface of the bone and creates that bedding. I use the term bedding because it is the bedding for a comfort of a future abutment. And you can see this is the same picture from different angles. You can see on the picture in the middle, you see a little releasing ring, okay, around the healing collar. Same thing on this picture. And you can compare both. And this is just to represent how we're sculpting the bone for different types and shapes of the teeth. You can see the standard osteotomy. You can see the next one to the right, which approximates a premolar. And on the very right, you can see osteotomy, which is very suitable for a molar. And this is just a representation of different types of osteotomy, which, again, shaped according to the tooth you're working with. And later on, we're going to show you in different cases how it accepts different types of healing colors and how you choose the healing color according to osteotomy you prepared. And again, this is standard, premolar, and molar. We're sculpting the bone. We're not just drilling the hole. We're not just introducing that thing called a drill to create an osteotomy for an implant. We are sculpting the bone. We're creating a future bedding for the abutment and future crown, and very, very good environment for the future soft tissue. In his book, which we refer many times because it's a wonderful book, and Dr. Linkevičius made a tremendous effort and a lot of research talking about this concept. And what we created with the drills fits exactly to what he's been describing in his book. One of those principles he's talking about is flattening of the alveolar ridge. Why is that? He tries to create an environment, the same thing we're trying to create, environment for the future abutment. Try to prevent the bone loss. What we decided to do with the drills, we're also kind of flattening it, but we are shaping it. We are sculpting it. If you take a look at this picture, this is again from the same book. Dr. Linkevičius is trying to, not trying, but achieving the osteotomy and shaping it to accept the molar or premolar. It's been done by a round drill. Just regular carbide drill, number 2 with a straight handpiece. There's nothing wrong with it. Everybody can do it, and it creates results. You can achieve the same thing we've been achieving with the universal shapers, but what if the drill slips? What if you going to the right or to the left and creating a different diameters?
So just so you notice, this bulb here is a little burnt out here. So if you look at the screen over there on your left, you'll see the bone and the shapes that we're discussing. Here's the shaping of what they're trying to accomplish in the zero bone loss concept for the future bedding of the implant, abutment, crown, all the design. So sometimes some of the animation, so if you want to just look back and forth so that we're all on the same page with what we're trying to accomplish here.
And just looking at this round drill, I remember when I was talking to Dr. Alexander Pozzi after his seminar, and I said to him, Doc, what are you using for your beautiful osteotomy, for your beautiful scalloping? And he says to me, well, I'm using number 2 carbide drill. And at that moment, it struck me that, we have to create something better than that. And again, flattening of the alveolar ridge. Compare first, second, and third pictures. The first one is at the level of the bone. The second one is a little bit above. But the third one is subcrestal. And again, it's been created to preserve future bone. This is the concept of zero bone loss. You can see the x-rays of the same implants, and you can see so-called bedding. I mean, actually, we coined the word bedding, and I use it all the time.
I think you like to sleep, Gary. I think that's why.
I do.
But keep your eyes on these pictures. Look and notice these pictures. Remember these pictures, because throughout the lecture, what we're going to be showing you is how to achieve this, and that's the most important part. There was a question there.
The same.
So the question is, just to repeat the question,
Yes.
was what's the minimum length of drill or implant? Oh, yes. What's the minimum length of implant to achieve it? We're going to go over that on a specific slide. Hold that for a moment. If we don't answer it, but you're going to see it very shortly. If we don't answer it, then stop us again.
Basically, the question is because here is like a 2 millimeters that you are reducing, and sometimes we don't have that.
Correct. Sometimes you don't have enough vertical length. You may have a sinus. You may have a nerve. We may have that. But hold the question for a minute, and then we're gonna try to answer
We'll
that.
address that.
And we'll go to it. But again, we're talking about the standard ridge. We're not talking about involving the IAN. We're not talking about a sinus. We have certain, obviously, situations. But the bulk that presents to us is hopefully not going to be. We'll have, a minimum of 10 millimeters of length to be able to do something. To me, an 8.5 millimeter implant is considered a solid implant. At this point, they're no longer small. And I think width plays into that factor. How wide you place the implant is going to affect the strength of the implant. So if we can get a little bit wider on those cases, obviously that's going to take that fear of fracture, of not having enough stability to handle the lateral forces in the mouth. So, but we're going to show you how to predict and how to plan. And is this going to be for 100% of the cases? No. That's why we have lots of tools. The person who only has one thing in their toolbox always looks at something one way. So as Maslow says, if all you have is a hammer, everything looks like a nail. But sometimes you need a screwdriver. So we have to think. Sometimes you need a power tool. So there's different scenarios. This is going to be for the bulk of the cases, but there's always going to be the outlier case.
And obviously, we have to follow the same principle of osteotomy as we follow with any other implant system. And when we designed this kit, we actually did not design it for any particular implant system. You can work with any system you want. So we're not worshiping one implant company versus another. We're trying to be agnostic. This is my very, very first case when I used the drill. And obviously, I picked the easy case, and just for the sake of testing it, even though we tested it on models, etc. As you can see, it's a maxilla, and it has very porous bone composition. So what we used it was 8.5 millimeter implant, osteotomy 8.5, and the diameter was 3.5. But we placed 5 millimeter diameter there, and the length was about 10 millimeters. How do we do it? Partially answering your question is the composition of bone dictates that we undersize osteotomy. But how do we deal with the cortical bone? You don't want to undersize cortical bone because then you cause pressure and so-called dieback of the bone in the future. So we'll show you how we did it. But it's a little bit slow because we used navigation, and when you use navigation, you have to watch where you're going. But basically, I did this with one drill. So the cortical portion of the bone was perforated, or I went through cortical portion of the bone with a flared portion of the drill. Okay? So therefore, it's precisely to the size I need. 3.5 diameter plus 2 millimeters of flare. It gives you 5.5 millimeters diameter. If you have 5.5 millimeters diameter and you're placing 5 millimeters implant, you have so-called releasing ring around the implant of 0.25, because that's diameter and this is just on both sides. All right?
It sounds confusing, but hang in there.
Yeah.
Because we're going to explain it in more detail and make an easy formula for you in a couple of slides. Again, I apologize for the quality here. To your left, you'll see a lot better video quality, so you can try to shoot back and forth between the slides.
And obviously, the cancellous bone inside was condensed by the implant. Implant was 5 millimeters and the osteotomy was 3.5. We're not afraid to do that because the composition of the cancellous bone is much, much softer than the cortical bone. And this is post-operative X-ray. You can see on the bottom a little flare, and this is 5.10, 5 by 10 implant. Talking about the bone, we need to recognize one thing. Not all bone created equal. A lot of implant companies, most of them, have the protocol of drilling, and they give it to you in the little brochure, and they say, well, type 1 bone, type 2 bone, type 3, etc. But there is no such thing as type 1 bone in one site. It's always going to be two types of bone, sometimes three types of bone, okay? And if we don't consider that, what happens, we create a complication. We compress the bone, we're placing the implant, we're trying to achieve so-called cortical stabilization, which is fine. But when we press the cortical layer of the bone, this is what happens. This is so-called dieback. In reality, it's a complication from excessive pressure. And this is another case. This is a beautiful case, very well done. Ridge split, augmentation, implants placed in the right position, the right sizes, and it looks beautiful. It looked beautiful in 2004. Some bone loss in 2012, still okay. But look what's happening in 2013, 1 year later. And this is 2014. This is bone compression. This is bone loss.
So what do we do now? We
What do
spray
we
a
do
little
now?
holy water called Arrestin. We use magic wands like Harry Potter called lasers, and we pray a lot. Or we have to do revision surgery. Too often we have to do revision surgery. So to try to eliminate that by the right placement, by choosing the right bone, the right preparation for longevity.
Again, not all bone created equal. Let's take a look at this slide. There's three slices of the same segment of the bone. In the very first one, we just took the measurement of the empty space, and it shows minus 1,000 Heimsfield units. These are units representing the density of the bone. And just compare this. This is cortical bone surrounding the cancellous bone, okay? Look at the density of the bone. It's 912. It's almost like a glass. It's like cement. And look at the inside slice. The density is 219. This is the same patient. This is the same segment of the bone. How do you deal with it? How do you approach varying bone density for the same exact osteotomy? How you deal with it using one drill. So that's the purpose of universal shapers. This is a dual purpose drill. Flare portion, bullet portion. You probably, most of you saw that video. It's on YouTube. This is invasion. This is aggression. This is violation of that peaceful coexistence of bone, soft tissue, blood vessels, etc. This is what we're trying to do when we do osteotomy. This is what happens. We invade the bone aggressively. We don't ask the bone. We don't follow the rules. We just invade. And then on top of everything, we're introducing a foreign body in there called implant. The funny thing is that it works. And the literature says it works at 95, 96% of the time. But as Isaac said before, is it? Is it working? Is it really working? What happens in a year? What happens in 2 years? How much of the so-called dieback you see? And then you have to face the patient. And you have to, whatever, holy water and whatever. And that's a problem. In this book, Dr. DiT-USA is describing the composition of cortical and cancellous bone. I don't want to bore you with histology and talk about osteoclast and osteoblast, etc., and composition of cells which respond to it. The only thing I want to say is the mineral composition of cortical or compact bone is about 90%. It's only 10% of the soft composition of the bone. How do you deal with it? how you go with regular osteotomy and preserve it. You can't. The cancellous bone has about 75% of soft composition, and this is where you can create your stability. It sounds a little bit controversial. You can create stability in cancellous bone, but if you undersize your osteotomy and go into cancellous bone, you can achieve that. However, if you undersize your osteotomy in the cortical portion of the bone, what happens? You create compression, it creates a dieback, it creates a problem. So whenever we look at the bone, let's look at the different portions of the site we're working with. And it's always going to be at least 2 types of bone present. Take a look at this slide. On the left side, it's the same slide. It's the same area of bone. Look at the composition of the cortical bone on both. Okay? Now let's take a look at the second slide and see how many types of bone we see there. We see cortical bone, we see cancellous bone, we see class 1, we see class 2, but look at the bottom. It's almost empty. Is it 4? Is it 3? How do we approach that? Obviously, if we have class 3, class 4 bone, we can use osteodensification. It's a wonderful tool. Probably everybody has it. But we cannot densify the cortical bone. The maxilla, most of the maxilla is cancellous bone. It's easier to work with. And yes, we can undersize our preparation there using universal shapers. But again, the entry point will be always the cortical bone. And we need to deal with it. So we cannot use the same approach to deal with varying types of bone using one drill, one type of osteotomy, and expecting the same beautiful results of 95%. Sometimes it will happen, but there is a but. So we came up with the concept of biological osteotomy. Biological osteotomy is not just drilling the hole. It's sculpting the bone, creating future bedding, creating the synergy between the abutment, implant, future crown. This line represents cortical release, which we were talking about just a second ago, and the whole area around it is sculpting area, okay? We are sculpting the bone. We're not drilling the hole. The whole zone there, we call shaping zone. And I think this is one of the most important slides you can take home, okay? You can take a picture of that, or it's also in your brochures, but this is very important. And this is one of the concepts in the universal shapers. Another very unique concept in the universal shapers is +1 concept. +1 concept is, if you look at the diagram on the left, the +1 concept is if you go deeper 1 millimeter, then you go 1 millimeter horizontally, wider. Let's say you have a certain diameter. Increase of the diameter in 1 millimeter will increase depth by 1 millimeter. If you increase diameter by 2, increases the depth by 2. Let's take an example.
The concept is that as you drill deeper, you're not just getting more length, you're getting more width. You're shaping the bone more. You're shaping that crestal out layer. You're creating it to be wider and planning for the implant to be deeper and more subcrestal. So we're scalloping, shaping the area by creating that depth.
And to partially answer your question, We'll give you an example. Let's say take this drill, a diameter 4.2 and length 8.5. And this is what you see here. And by the way, if you want to drill to length and use only 8.5 millimeters length, you can do it. It's the base of the drill. And also to add to your question, if you have soft bone, but as you said, you have outer layer, which is hard cortical bone, okay? By all means, use densification drills, but then you can take a little tiny drill, which is in the kit. It's called cortical release kit, and just tap it. So you're releasing your cortical bone, but your cancellous bone is all densified.
We'll explain that more.
Yeah. So let's say we increase by 1 millimeter in width and depth. And now we're creating the size of the implant of approximately, osteotomy of approximately 5.2 to 9.5 millimeters. And if we go further, we increase by another 1 millimeter, and we go to the diameter of 6.2 by length of 5. So these are various sizes you can play with using these drills. So this is all +1 concept. Here's another concept. Let's say you use your last drill, which is in red, and you flared your osteotomy to 4.5, or you flare your osteotomy to 5.5. Right next to it, you can see the scallop-shaped drills, which show the diameter. And what else you see is that those diameters will correspond to the healing colors which you pick to close your implant. Let's say if you work with, if your final drill was 5 millimeters diameter or 4.5, you're picking up the healing color which is 5 or more. If you're going to the next one, you pick your healing color which is 6 or more, or 7 or more. And I like those healing colors. This is Megagen healing colors. They have this beautiful S shape. And again, as Isaac said, you have different diameters, different heights, and I use them all the time. This is the picture you saw before, okay? And this is the kit. This is Universal Shaper's kit. I want you to take a look at this picture. We call it an ugly picture, but we decided to keep it. And you don't have to take your photograph, but take a mental picture of that, because we'll come back to it later.
This is when I told Gary he needs to buy new mirrors for his, his photographs.
Yeah, but we decided to keep it for that reason. You can see a release ring around the implants of approximately 0.25 to 5 millimeters.
Yeah.
It's a gap there. And I still vividly remember, like on the stage, Dr. Alan Simon-Pierre screaming, why can't we have a release around the implants? Why can't we prepare the osteotomy so we can have some breathing room for implants? It was about, I would say, like 4 or 5 years ago. This is releasing ring around the implants. This is how the osteotomy is done. It's one of the many cases we do. It's just to show you the working of the drill. The implant is placed, but what's more important is the picture on the right. Look at the osteotomy. Look at the ring around the implant. Look at the releasing zone. This is the future bedding of your implant, abutment, and soft tissue. Now, I think everybody here encountered this problem with placing beautiful implants in nice solid bone, and then we put healing colors, and this is what we see on the x-ray. And by the way, we should take x-rays all the time. We place healing colors. Lack of bone profiling, hindering seating. That happens with healing colors, that happens with multi-unit abutments. We'll show later how we deal with it and beautiful results we can get. This is the lack of bone profiling. This is just enlarged picture. And this is the kit, which probably we all know. Every company has their kit for bone profiling. And when abutment is not fully seated or multi-unit abutment is not fully seated, we use that kit. This is the sleeve, this is the guide pin, and the profile itself. We have to go through certain steps. We put the pin in, place the bone profile base, then we profile the bone with a profiler. We have to be very careful to prevent damage to the fixture. Finally, we unscrew the peg, and this is a beautiful result. It's a very good result. And we can place the healing abutment back, or we can place multi-unit abutment back. We have to go through all the steps to achieve what you see right now. But what if you use just one drill? And you get the same results. Doing osteotomy, doing the profiling, creating a very, very favorable environment for your future implant. And you don't have to go through all the hassle. And this is done in a couple of seconds.
So this was a case that I did many years ago. I actually showed this at the Osteodensification Symposium, the first one that we had back in Orlando. And we placed the implants guided through a surgical guide. When we did that, we used the densifying burrs to place them. So we weren't widening out the crest. We were trying to expand it. But we still have a defect, and we can't leave these defects. What's going to happen if we leave this alone? We're going to have food traps. We're going to have the patient having very uncomfortable brushing episodes. They're going to complain. We create what I like to call dessert trays. You leave too much space underneath the buckle of the crown. The patient goes for dinner. They come home. They do a little swipe with their tongue. Ah, dessert. 2 hours later. It's not fun, especially when you're paying lots of money to get a tooth. The patient didn't come to you for an implant. They came to you for a tooth. And a tooth doesn't usually have food stuck there if it's natural and how it should be and we're maintaining. So we see that we have a lack of bone profiling here. So we're going to have to modify this. We're going to have to change the shape to accommodate. And in this case, we're doing an immediate load. So we're going to put a final zirconia abutment. So the first thing we do is put that guide pin on. We use the bone profiler, and we create the space. We create the emergence profile. This is what we do. It's standard implant placement to allow the acceptance of the shaped final abutment. Here we use temporary crowns, and we inserted them the same day. We torque them in. That wonderful feeling when you put on the temporary, and you put it on and it just fits perfectly and you don't have to adjust anything. Such a great feeling when you have these cases done. You know the patient's leaving with teeth and all is right in the world. But we have to augment. We have to veneer graft in this case. Since we placed the implant, we put some xenograft here and just some PRF over the top. We weren't revisiting any time. We weren't planning on revisiting, and thankfully we didn't. So we placed the graft. We put the PRF over the top. You can use collagen, whatever you like to do, and whatever your format may be, but just to hold the space out. Thankfully, we didn't have to do soft tissue grafting, but we took care of the frenulum at the same time, so there wasn't any muscle pulls, proper suturing, trying to coronally reposition the flap a little bit so that we can accommodate for potential recession over the implants, over the implant crowns. And this is how the patient leaves. You can see we pull down the tissue, the excess tissue, trying to preserve the papilla. And the patient comes back a few weeks later, and the tissue's looking good. I like excess tissue. I can remove excess tissue. Hard for me to grow tissue, easy to take away. Lasers are wonderful. You can use them very, very quickly to sculpt. So the more tissue I have, the better. The abutments look beautiful. The fixtures look beautiful. We decided to remove everything because we wanted to test ISQ. We were beta testing this new C-guide concept with Versa. And at 3 months, we took some ISQs, but we got a chance to look at the soft tissue around it when we profile. And we have beautiful emergence profile. You'll see a little piece of xenograph still left in there. Xenograph never likes to leave, always sticks around. Keep that in mind. So it's a great scaffolder for cases like this. I don't love it for regeneration all the time. I like allograft. I like autogenous bone. I like to grind teeth for bone. But xenograph has its wonderful place for being a great scaffolder and holding out and bulking out the tissue here. So we have beautiful soft tissue response. 5 years later, patient presents again. This is a nephew of a neurosurgeon who asked me to treat the entire case for him. And you have beautiful results after 5 years and looking wonderful on the post-ops from the side views. So we have good, stable soft tissue over the longevity of its time. So this method of creating the emergence profile, we know it works, and it works on the x-rays 5 years later. We see we're not getting dieback. We're getting fill of tissue, and sometimes even bone, filling those areas that we've actually removed. It pushes away, but we create the space so healthy bone and tissue reforms. But the process, because of the guide pin, is a little more laborious. It would be nice to have one drill I could just use to accomplish it all. Required many drills in this case. And it's a lot of effort to make sure you go through it. Not everybody wants to put in all that effort each time and have several kits, because each time you bone profile, if you're placing implants, you got to sterilize that kit. You need to have another backup kit. And then you need another backup kit and another one for every case that walks in. I had 4 cases yesterday of implant placement. I would have needed for each one of those profiling for each case. I had excess bone, needed to remove them. One was an immediate load. On a socket shield case that one of the attendees here brought a patient from Vermont to come down to our office, and we treated it yesterday. We had to profile it to be able to see it. But now we're profiling differently using the shaper burrs instead of having to worry about using several different drills for these cases.
This is the bone profiling. This is the bone profiling. This is what we first we called flattening of the ridge. It's done by scalloped shaped drill. If you notice, it's wobbly. It's wobbling all the time, and it's not stable. So what we did, we created a new design. It's a little bit chunkier, has the cylinder in the middle, and what it does a couple of things. Number one, it brings tremendous stability to the drill. You cannot distort it. You can drop it as many times as you want. You will not distort it. And one of the features of that is when you place your implant between 2 teeth, you can kind of visualize the distance between them. You can see a future width of your abutment. It's like a guide. It's a visual guide. So if you have certain space between the teeth, you can kind of approximate what's going to happen next. Okay, that's another use. It's more stable design.
And you can see how much more stable the new design is. It's not skipping all around. It's holding its integrity, able to scallop the bone, to shape it appropriately.
Once in a while, it will skip if you're on let's say on the gingiva. When you do deepitalization, we'll get to it later. But right after that, we go with the bullet-shaped drill, and osteotomy is done. Look at the picture right here. Why is it important? This is right next to the canine, and I'm sure all of us experience this problem. We're next to the canine, we have this slope, and how do we deal with it? Because it's different height. It's higher next to the canine and it slopes down. How do we deal with it? This is how we deal with it. We're creating a custom-made osteotomy. We created a custom-made bedding for the future abutment. Some clinicians try to place the osteotomy a little bit distally to avoid that slope. And what happens? You have foot impaction, you have a gap, and you have problems. Some clinicians try to place it very close to the canine, and then you have dieback of the bone again. So this is a custom-made bedding using just 2 drills. And this is how it looks on the X-ray. One of the cases, by the way, done by a student in Tijuana course in Mexico in Advanced Implant Education Program, first-time user. And again, you see the shaping zone, you see the drill.
Scallop design.
It's scalloping the bone, creating the bedding, creating a very, very comfortable environment for the future restoration. And these are 3 implants, again, placed by students. And you can see profiling of the bone. You can see a ring around the implants. It's a future bedding. You see the peaks of the bone. This is where keratinized tissue is going to be resting comfortably. This is another use of the drill, partial extraction therapy. We're using a lot of drills to get to the point where we bevel it, creating the gap, but we can do it with 1 drill. Look, we're tilting the drill 45 degrees and creating inside bevel. Then we're doing osteotomy with a bullet-shaped drill, and we're inserting the implant. And what's important is after implant insertion, we need to have a gap. And using the drills, the gap comes out automatically. Why? Because it tapers out by 1 millimeter first and then 2 millimeters. So you automatically guaranteed that you're going to have a gap, which is extremely important in this kind of procedures.
So this is a case that presented to my office for standard implant treatment. There was severe decay, and it was extending far below the tooth. We had a small fracture. We had pain, a small vertical fracture from the CBCT, and the tooth was deemed for extraction. So we looked at it. We temporized it till the patient could come back in and do the actual procedure, and our goal was to do an immediate load on this case. I didn't have time to make a guide. This was a rush case. The next day, we brought him back in to treat the tooth. And I didn't have time to plan it guided, so we went with the standard way. And this is how we presented. So in this case, the root was fractured to the gingiva. We took the drill and we just went straight through, and we plowed through. This does not replace partial extraction therapy kits like the one by Howie Gluckman, which I use all the time, which I use for this case as well. But I can prepare my osteotomy first. For those of you who are used to the drill through root technique, where you drill through the roots to place your implants and then extract the part of the tooth or extract the whole tooth, this is the same concept. We can prepare our osteotomy first, remove the rest of the fragment second, and then go ahead and place our implant. But you can see we're starting to prepare through the actual root itself. And then we're going to take it to the next step where we remove the other portion of the root, leave the buccal surface, buccal part of the root intact. We shape it using several drills. So it doesn't replace the kit, it just helps aid with these kits. And as most of you know, I'm a massive fan of partial extraction therapy. We've given lectures at Dental XP over many years and hands-on courses on this. It's a wonderful technique. I can't teach this all to you today. If you haven't done it, I can't teach this to you in this one short hands-on. But there are lots of articles out there. There's tons of them by our group, which is the Partial Extraction Therapy Group, which consists of a tremendous reach of all across the globe. We have people from Croatia, from South Africa, from the United States, from Japan, from all over the world on this group. We contribute to lots and lots of journals. These are just some of them that I've been very proud to be a part of, including a 10-year retrospective study. And as I was mentioning earlier today, I had a patient come in. It's 11 and a half years, and the tissue still looks amazing. So it's a wonderful technique, needs to be done correctly. You do it the wrong way, you're going to have trouble. do it the right way, you can have incredible success. Even more success than you do with standard implant placement. And we have histologies now. We have one by Chuck Schumer. We have one from the Greek group with human histology showing bone growth between the shield. So it's great that we have a shield and a root that we can combine. So we can use this technique. We can place our implant. We can take our ISQ to see if we can load. We need to know if we can load these implants the same day. We can't just rely on torque. We need to know the integrity of the implant. We want to be repeatable and an objective measure. And so we use an implant stability quotient, radio frequency analysis, such as this one by Ostel. This is a wireless one that I use every day in my practice now. We take our ISQ. We had great numbers. So we're going to fabricate temporary crown immediately. We have a rubber dam to block out any excess material that's going to go into the area. We don't want any composite material. We use the temp tab, a moldable temp tab at the start of the procedure to capture the existing tooth, and then we just popped the hole and created a screw-retained crown, and we temporized it immediately, put some Teflon, and put some composite to try to sculpt the tissue. And you can see the temporary. This is how the patient left. And when we come back just a few months later, and we uncover and we're ready to take our final impression, we see this magnificent tissue, and we get excited. We get elated because we know we're going to have a beautiful final crown. So by sculpting the bone, by keeping the root fragment in this case, by using the proper burr, we were able to scallop the architecture appropriately, even for cases of use of partial extraction therapy. We are in development of a new burr that's going to make it even simpler for partial extraction therapy that consists of another added component to make this process even simpler. So this is the start. This is the first kit, and there will be other kits that we'll come out with over the next subsequent years to keep improving upon the shaping and scalloping of the bone. And then we can look at that soft tissue and we can marvel at it. We can look at it and say, this is a year later. Look at the plaque that's developing around the adjacent teeth and the food traps. But look at our beautiful crown. No food traps. We're not getting plaque about that. Henry just left. I wish he didn't, because he always tells me not to show teeth like this. So like, you clean them up before you take the picture. Let it look good. But it's not the case for this. I want to show you. Look at the tooth in question, wasn't touched, and look at the other teeth, how they're building up. So we get this beautiful fighting ability by keeping the bone intact, by scalloping it, and having very nice scalloped architecture, preserving and being able to keep the architecture intact and creating an emergence profile with the right type of shape for our final crown. Let's go through this, and then we'll take a quick break.
Yeah, this is just to show the...
Mic up.
This is basically nothing special, just to show that you can prepare 3 osteotomies using just one drill. It's 3.5 by 11. Advancing it into the bone, you can advance it 1 millimeter, then 2 millimeters, and because it's an extraction site, you don't have any interference with the bone. You can advance it as much as you want. And again, I used only one size drill. And this is all ISQs, which is very important, you know, whether you load it or not, you know whether you're putting healing abutment or not, and you know how to predict the future restoration. And this is just pre-op and post-op. Implants are in place, bone graft is there, and this is soft tissue outcomes. And this type of outcomes you're gonna get every time you're using the drills, every time you're creating the bedding for your abutments, and scalloping the bone. This is immediate placement. Tooth is mobile, decay, extracted the tooth, and first we created an osteotomy, a regular osteotomy. I took this video because I just wanted to show how you use the drill with any osteotomy from any system. We gently put it in, and first movement is 1 millimeter, and then 2nd millimeter. Look at the scallop shape of the osteotomy. This is your future bedding for an abutment. It has about 1 millimeter flare horizontally and 1 millimeter flare vertically. This is the ring around it. This is release zone around it. This is how it looks. Remember this picture. Next slide will be soft tissue, and this is going to look exactly like this. The crater, the flare, covered with the soft tissue. And that happens every single time. And then the implant placement. Again, it's uneventful. Implant goes in, and look at the releasing ring around it. The releasing ring is about 0.5 millimeters, and this is good enough to accommodate a wider healing color. I always use a wider healing color. For premolars, I usually use 6 millimeters. For molars, I use 7 and up. And this is what you see all the time. The ISQ here is 80. But what I want you to take a look at is the area around the neck of the implant. It looks like it lacks bone. It looks like there is no bone. And there is no bone, because I scalloped it. I created a release zone around this implant. And you might wonder, well, you don't have bone. How is it going to survive? What's going to happen? This is what's going to happen. We put the healing color. We call it tissue former, because we need to form the tissue. Take a look. There's still releasing area around the implant, and there's no bone. This is how tissue looks after maturation in about 3 months, probably less than 3 months. Look at the neck of the implant. Look what happened. The bone remodels right at the crest of the implant. The implant is fully submerged into the bone, and the bone starting to creep onto the platform of the implant. This is your biological platform switch. This is your bone platform switch. This is your releasing zone becoming a bone zone. Future bedding. This is final restoration. This is releasing zone around the implant, and this is what you're going to get every time.
So we've created the releasing zone around the implant by using the drill. You can see the spacing that's created. We fixed this screen, so see a little bit better now. Created that releasing zone. We have that room for the implant to breathe. I like to put it in different colors so I can appreciate it. So I take it in and out of black and white so you can see the sculpting. You can actually appreciate it a little bit more. And the same with the tissue healing. The soft tissue outcomes are really exceptional. We get this beautiful soft tissue turnover. We get excellent tissue forming. We can really capture it appropriately. And this is where now it's up to you to react quickly, to take your impressions quickly, to capture the sulcus or do your digital scanning. But do it quickly. Don't waste too much time, because you work so hard to get this tissue, you don't want it slumping very, very easily, because you really want to transpose that to the lab. So if you get ridge lap type of crowns back from your lab, and often it's because you think you have great tissue, but really your tissue is slumping, it's no fault but our own. So we like to use the composite trick or immediate scanning. So don't always look at the lab and try to yell at the lab. Try to look and see how you can improve to make it easier for the worst person in the laboratory to do the best work for you. It's not rocket science. It works very easily if you put the right tools in their hands. When we go back to the Zero Bone Loss Concepts book, we compare and we see and look at the same scalloping, same type of ideology. We get this nice scalloping of the bone to create beautiful soft tissue. But what started here turned into here with a tissue former to be able to create and keep that tissue. So we're getting that bone zone, and we're keeping it, and we're shaping it for development for the future in the same fashion and without having to use more, more aggressive techniques like a round burr. So you have Gary's example on the left side of the screen, and you have Tomas's scalping on the other side. The only difference is, one, you're using a round diamond burr and trying to control, and it may wobble, and if you've used, not round carbide burr, if you use those, sometimes they're very aggressive, and they remove too much. So it's nice to have a more controlled area. And you can see on the lingual, because they were using the round burr, carbide burr, they removed too much from the lingual. That was unnecessary. They have the right amount on the buckle, but on the lingual, there's too much removed. So having the right tools in your toolbox to help you and hold it in the right fashion. So you remember this picture. This is the ugly duckling picture Gary told you about before. Horrible mirror, horrible picture, but look at the releasing ring. And what does it become? This is the ugly duckling developing into the swan. And we have beautiful space for both the premolar and the molar region. So we're going to get this more predictably.
And
Okay.
look at the difference in sizes. So the premolar area was created by 5 or 6 millimeters scallop shape, and the molar area was created exactly in the same mode we showed you in the models, which we're going to go over at hands-on. And this is pre-op, one of the pre-op pictures. We're placing 3 implants. These are 3 osteotomies. Notice again the shape for the molars. Okay? It's all scalloped. It's all a little bit elongated. And we always going to get those soft tissue outcomes. Case after case after case. This is the upper. These are 2 premolars. Again, they're almost identical. Look at the soft tissue. These are soft tissue outcomes on every single case. And also always repeatable and predictable.